New SpaceX engine might take humans beyond our galaxy as a discovery that raises scientific, technological, and existential concerns about the future of interstellar travel. SpaceX, known for pioneering reusable rocket technology and deep space exploration, has reportedly developed a new propulsion system that could revolutionize space travel. Unlike traditional chemical rockets, this engine is designed to operate using next-generation propulsion methods, possibly involving nuclear, ion, or antimatter-based technology. If successful, this engine could drastically reduce travel times between planets, moons, and even nearby star systems. Current space travel is limited by chemical propulsion, which is inefficient for long-distance missions beyond our solar system. Traditional rocket engines burn liquid fuel and oxidizers, requiring massive amounts of propellant that make interstellar travel impractical. SpaceX's new engine is rumored to be based on nuclear thermal propulsion, fusion technology, or electromagnetic acceleration, all of which could enable faster travel. Nuclear thermal propulsion could allow missions to Mars in just weeks instead of months, greatly enhancing human space exploration capabilities. Some scientists speculate that if this technology advances, it could make interstellar travel to the closest exoplanets, such as Proxima Centauri b, theoretically possible. A major challenge for interstellar travel is achieving speeds close to a significant fraction of the speed of light, something no human-made spacecraft has done. Breakthrough Starshot, a project backed by scientists including Stephen Hawking before his death, proposed using light sails propelled by lasers to reach Alpha Centauri. If SpaceX's new engine is capable of sustained high-speed travel, it could surpass all previous concepts for sending humans beyond our solar system. One possibility is that this engine relies on ion propulsion, which uses electrically charged particles to generate thrust over long distances. NASA has already used ion propulsion on deep space probes, but SpaceX's version may be scaled up for human missions. Some theorists suggest that SpaceX could be working on a fusion-based propulsion system, similar to those proposed for future interstellar probes. Fusion propulsion, if successfully developed, would use controlled nuclear reactions to generate immense energy for high-speed space travel. Another possibility is a warp drive concept, which involves bending spacetime to create faster-than-light travel, though this remains theoretical. If SpaceX's engine can generate continuous acceleration, it could allow missions to reach the outer solar system in weeks instead of years. One of the greatest challenges in space travel is fuel efficiency, and a new propulsion system could eliminate the need for massive fuel reserves. SpaceX CEO Elon Musk has previously stated that making humans an interplanetary species is his ultimate goal, and this new engine could be a step toward that vision. A breakthrough propulsion system would greatly increase the feasibility of colonizing Mars, as well as exploring moons such as Europa and Titan. If SpaceX has successfully developed a high-efficiency propulsion system, it could make space mining, asteroid exploration, and deep space habitats a reality. Some scientists believe that interstellar travel may require antimatter engines, which would use matter-antimatter annihilation to produce enormous thrust. However, antimatter propulsion is currently theoretical, requiring technology far beyond modern engineering capabilities. If SpaceX's new engine is based on plasma propulsion or electromagnetic acceleration, it could generate thrust using magnetic fields instead of combustion. Such an engine would operate continuously, allowing spacecraft to reach higher speeds over time rather than relying on short bursts of propulsion. A major question remains how this new technology will handle deep space radiation, fuel efficiency, and the extreme conditions of interstellar travel. Some experts argue that even with advanced propulsion, human bodies may not survive long-duration space missions due to radiation exposure and microgravity effects. If SpaceX's engine makes interstellar travel feasible, it could open discussions about generation ships, cryogenic sleep, or AI-driven robotic exploration. Critics argue that even with a new propulsion system, sending humans beyond the solar system would require advancements in life support and shielding technologies. NASA and the European Space Agency, ESA, have been researching nuclear propulsion and advanced ion drives, but SpaceX may have taken the lead in developing a working prototype. If SpaceX's breakthrough engine works as intended, it could redefine the future of space travel, making colonization of exoplanets a possibility rather than science fiction. There is speculation that SpaceX may collaborate with NASA's Artemis program, the Mars Society, or private space exploration initiatives to test this technology. A major concern is whether current space treaties and regulations will be updated to accommodate potential interstellar travel capabilities. Some scientists warn that interstellar missions could bring risks, such as unintended contamination of alien ecosystems or unforeseen cosmic hazards. If the new engine is capable of reaching speeds close to 1% of the speed of light, it could allow a spacecraft to reach Proxima Centauri in a few hundred years. While this is still far from true faster-than-light travel, it represents a significant leap forward compared to today's technology. If the propulsion system is tested successfully, it could pave the way for deep space colonization, asteroid mining, and robotic exploration of distant exoplanets. Some theorists suggest that an advanced propulsion system could lead to autonomous AI-driven spacecraft capable of exploring the galaxy for centuries. If SpaceX's new engine is truly revolutionary, it could inspire a new space race, with other countries and private companies accelerating their propulsion research. The ethical debate surrounding interstellar travel also raises questions about humanity's role in space exploration and our responsibility to preserve alien worlds. Some believe that interstellar exploration should be robotic first, reducing the risks of human loss and ensuring planetary protection. If this engine proves successful, it may lead to advanced space stations, lunar bases, and interplanetary transport systems within the next few decades. Ultimately, the debate is not just about whether this engine works, but whether humanity is ready to take the next step toward becoming a truly spacefaring civilization. The real question is whether SpaceX's new technology will break the limits of human space travel, or if we are still centuries away from reaching beyond our galaxy.